In the farthest reaches of our solar system, a small, icy world cloaked in toxic frost hangs in the vast emptiness. A colossal, unyielding shadow drapes across its rugged mountains, blotting out the starlight. Even the distant sun struggles to pierce the perpetual twilight that blankets the frozen plains, creased with deep, unseen chasms. This is Pluto, a realm of rock and ice, shrouded in eternal darkness. Let's delve deeper into its mysteries. Far out, at the edge of our solar system, lies Pluto, a world shrouded in darkness. Its distance is staggering, a whopping 40 astronomical units from the Sun, making it a faint and indistinguishable speck. Unlike planets with nearly circular paths, Pluto's orbit is quite elliptical, taking a lengthy 248 Earth years to complete. While small compared to planets, Pluto used to be considered the 9th planet, but its size tells a different story. At just 1,188 kilometers in radius, it's even smaller than some moons, including Earth's own. Precise measurements revealed its mass to be a mere 18% of our moons. These characteristics align Pluto more closely with dwarf planets like Eris and Ceres, leading to its reclassification in 2006. Pluto's elongated orbit means its distance from the Sun constantly changes. In 1989, it reached its closest point, perihelion, since its discovery, venturing 29.7 astronomical units. However, this distance is steadily increasing, and by 2113, it will reach its farthest point, or aphelion, at a staggering 49.3 astronomical units. This extreme distance makes Pluto invisible to the naked eye and even appears as a blurry brown speck in powerful telescopes like Hubble. Studying its surface details under such conditions is extremely challenging. In 2006, a brave robotic explorer named New Horizons embarked on a momentous journey to unravel the mysteries of Pluto. Its destination was a staggering 9.5 years away. During its epic voyage, New Horizons provided us with breathtaking close-up views of Jupiter. Finally, in 2015, New Horizons reached its primary target. As it zipped past Pluto, the spacecraft performed a scientific blitz, making a whopping 400 observations and gathering over 6 gigabytes of data. However, due to its trajectory, New Horizons couldn't capture the entire dwarf planet. Instead of orbiting Pluto, it performed a flyby to efficiently explore other celestial bodies in the future. Before diving into Pluto's surface features, let's peer beneath its icy shell. Scientists believe Pluto harbors a massive core, roughly 1,700 kilometers wide, composed of a mixed rock and various ices. This core is encased in a 300-kilometer thick icy mantle. Interestingly, there might be ongoing tectonic activity within this mantle, but much remains unknown about these processes. The outermost layer is a crust, a frozen cocktail of gases like nitrogen, methane, and carbon monoxide. Some theories suggest that Pluto's core generates enough heat to partially melt the icy mantle. If this is true, a hidden ocean of super salty liquid laced with dissolved ammonia could exist beneath Pluto's surface. As for the surface temperature, it's a bone-chilling negative 213 degrees Celsius or a mere 60 Kelvin. Our exploration of Pluto begins with its most captivating and well-studied feature, Tombaugh Regio. This vast, heart-shaped region dominates Pluto's equator, earning its nickname from its uncanny resemblance. Spanning a staggering 2,300 kilometers, it occupies a quarter of the dwarf planet's entire surface. Tombaugh Regio boasts a diverse landscape. Sputnik Planitia, a smooth, bright plain in the western section, is a geological marvel. Clocking in at 1,492 kilometers wide, elevation maps reveal it as a vast, low-lying expanse. This icy wonderland is blanketed with thick nitrogen ice, along with carbon monoxide and solid methane. These substances boast high reflectivity, with some areas bouncing back a whopping 90% of incoming sunlight. The near absence of craters hints a geological young surface. The prevailing theory suggests Sputnik Planitia formed roughly 100 million years ago from a colossal impact with another celestial body. This impact likely carved a massive crater that subsequently filled with material from Pluto's hypothesized internal ocean, which can rapidly froze. Supporting this theory are the plane's characteristics features: smooth, 20 to 30 kilometer wide surface areas with bordering hills and depressions resemble convection cells, a pattern formed in fluids heated from below. This could be an indirect clue to a warmer interior within Pluto. Towering mountain ranges border Tombaugh Regio. To the west of Sputnik Planitia lies Hilary Montes, a formidable chain reaching 3.5 kilometers in height. The southern region boasts Tenzing Montes, the undisputed king of Pluto's mountains, with some peaks soaring over 6 kilometers above the average surface level. Remarkably, these mountains are likely composed primarily of water ice, which in Pluto's frigid temperatures is as solid and unyielding as rock. Venturing south from Sputnik Planitia, we encounter a captivating sight, a deep basin encircled by massive, layered ridges of ice and rock. This intriguing formation is a strong candidate for an ancient cryovolcano. Imagine a volcano that erupts, not with molten rock, but with super cold ices and other volatile materials. The surrounding rocky terrain is believed to be the solidified remnants of numerous past eruptions. Studying the chemical composition of these frozen flows could be a game changer. By unlocking their secrets, scientists might be able to peer deep within Pluto and decipher the composition of its hidden layers. In stark contrast, the eastern portion of Tombaugh Regio paints a different picture. Here, the landscape is draped in a darker hue and riddled with craters, hinting at a much older and battered surface compared to the youthful Sputnik Planitia. Our equatorial journey continues eastward, where we encounter a chain of intriguing dark spots, each hundreds of kilometers wide. Known as maculas, these enigmatic features are named after dark deities from various cultures, with one such spot even bearing the name Balrog. Collectively, they form a giant equatorial structure named the Brass Knuckles. Towering mountain ranges separate the maculas, their surfaces etched with deep crevices stretching for hundreds of kilometers. West of Tombaugh Regio lies Chulu Macula, the undisputed king of these dark spots, measuring a staggering 3,000 kilometers across. Unlike the reflective brilliance of nearby Sputnik Planitia, Chulu Macula reflects a mere 30% of incoming sunlight, creating a dramatic contrast. The true nature of the maculas remains an enticing puzzle. The prevailing theory suggests their dark coloration stems from a high concentration of tholins, complex hydrocarbons formed by the interaction of sunlight and cosmic rays with methane and nitrogen in Pluto's atmosphere. Additionally, the abundance of impact craters hints an ancient and heavily bombarded surface. Chulu Macula itself displays remarkable heterogeneity. Undulating plains dominate the western region, while the central portion boasts a smooth expanse. The easternmost reaches are crowned with mountains and pockmarked with craters, painting a diverse geological landscape. Bidding farewell to the enigmatic Chulu Macula, we embark northward to explore Lowell Regio, a vast valley cradling Pluto's North Pole. Surprisingly, this region currently basks in the most sunlight on the entire dwarf planet. The key lies in Pluto's unusual tilt. Unlike planets with relatively straight up and down rotations, Pluto's axis spins at a dramatic angle compared to its orbital path. This peculiar tilt has resulted in the North Pole currently facing the Sun. Scientists believe this orientation is responsible for a fascinating phenomenon, a threefold increase in Pluto's atmospheric density over the past 30 years, despite its growing distance from the Sun. The theory suggests that solar radiation is vaporizing nitrogen ice deposits at the pole, enriching Pluto's thin atmosphere. This unique tilt also contributes to a number of peculiarities in Pluto's orbital motion compared to the planets of our solar system, which we'll explore next. Pluto's oddities extend beyond its tilted axis. The dwarf planet exhibits a curious wobble in its orbit, a celestial jig caused by its surprisingly large moon, Charon. Charon's mass is a hefty 1.52 by 1,021 kilograms, a whopping 11% of Pluto's own mass. This impressive size results in both celestial bodies orbiting a common center of mass, a point located slightly off-center from Pluto's center. The gravitational dance between Pluto and Charon creates a fascinating phenomenon: tidal locking. They forever face each other with the same sides, a slow waltz where neither ever reveals their hidden backside. Charon's surface boasts a darker visage compared to Pluto's, dominated by water ice with only traces of methane and nitrogen in certain regions. While Charon reigns supreme as Pluto's dance partner, the system isn't without other celestial companions. Several much smaller, irregularly shaped moons complete the picture. Discovered in 2005, Nix and Hydra measured just tens of kilometers across. Kerberos and Styx, even later discoveries, are mere pipsqueaks at under 16 kilometers in diameter. All these moons share a common thread. They're primarily composed of water ice, likely captured by Pluto's gravity from the vast reservoir of ice objects known as the Kuiper Belt. While New Horizons couldn't capture Charon's entire surface, the glimpses we have are truly captivating. South of the equator lies a vast region dubbed Vulcanplanum, stretching over a staggering 400,000 square kilometers, comparable to a European country. This realm boasts Charon's highest mountain, the mighty Kubrick Mons. Measuring roughly 40 kilometers wide, some estimates suggest it reaches a height of 4,000 meters. Encircling Kubrick Mons is a curious feature: a vast circular moat plunging 2 kilometers deep. This hints at the possibility of Kubrick Mons being a cryovolcano. If so, the surrounding terrain might have sunk due to the depletion of an underground reservoir that once fed the volcano. North of Vulcanplanum lies a stark contrast: the heavily cratered plains of Oz Terra. A dramatic system of cliffs and chasms, reaching a kilometer in height, separates these two regions. Serenity Chasma, the Grand Canyon of Charon, reigns supreme here. This colossal gash stretches 200 kilometers long, varies in width from 40 to 50 kilometers, and plunges a staggering 7 kilometers deep. Exploring its depths is a challenge due to the perpetual shadows cast by the steep slopes. Nearing the North Pole, we encounter the enigmatic Mordor Macula, a giant dark spot stretching 475 kilometers across. Its origins remained a puzzle. The leading theory suggests it formed when nitrogen and methane from Pluto's atmosphere drifted over and became trapped by Charon's gravity. Exposure to ultraviolet radiation would have then transformed these gases into tholins, which gradually concentrated in Charon's icy plains. However, this hypothesis awaits further exploration. Charon remains largely an enigma, with much to be discovered. While the Pluto-Charon system is undeniably one of the most intriguing structures in our solar system, it's far from fully understood. New Horizons has long departed its vicinity, and both Pluto and Charon are steadily receding, taking their secrets deeper into the cosmic distance. Currently, the Valiant probe resides over 50 astronomical units away, occasionally beaming back invaluable data. By 2030, its journey will likely end, leaving it alone in the frigid embrace of space. And if you like this video, click the next one shown on the screen. I'm sure you'll like it. Thanks for watching.